Okay, so for this unit, we have simplified rational roots. We have explained what a radical is. We've used a calculator to simplify roots, and we've distinguished between rational, irrational, and imaginary numbers. What you're going to do today is place square roots on a number line, which you started in the Desmos, determine the two integers, an irrational radical is between, and estimate square roots to the nearest tenth without a calculator. In the Desmos that you did, you first were placing rational radicals on the number line. For example, the square root of 16, the square root of 81, the square root of 225, and the square root of 1, where the radicand was a perfect square. So we ended up right at an integer. But then you were asked to estimate some irrational radicals, and you had to know that something like the square root of 8 fell between 2 and 3 and much closer to 3. One strategy for placing numbers on your number line is to write the equivalent radicals below each integer. So beneath 2, I'd write square root of 4. Beneath 3, I'd write square root of 9. Beneath 4, I'd write square root of 16, all the way across. This is a really good strategy because it helps you see how far along to place each value. So since square root of 8, we'd be able to fit in here square root of 5, square root of 6, square root of 7, square root of 8, and square root of 9. We can approximate about where square root of 8 would fall. Now, this isn't actually a linear relationship, but it will work for approximating. On today's warm-up, you were asked to approximate the square root of 34. So we already know the square root of 36 is 6. And so the square root of 34 is going to be slightly below that. So a good estimate for that would be something like 5.9 or 5.8. Because the square root of 34 is slightly below the square root of 36. Now, if you actually wanted to prove which is closer, you would actually need to try 5.8 times 5.8 and 5.9 times 5.9, and you would see which of these is in fact closer to the square root of 34, which when I did it on my calculator, it does come out closer to 5.8. In general, when we estimate, I will accept your answers within 0.1. So I would accept 5.8, 5.9, and 5.7 for this one, although 5.7 is a little far off because 34 is so close to 36. Here's a nice visual to help you. So on your number line, we were looking for the square root of 34. And we know that 5 is the square root of 25, and 6 is the square root of 36. So I would recommend that you always have your bookmark out to the side. And you're literally going down this list and you're seeing, okay, 34 isn't on this list, but it does fall between these, which means that the square root of 34 falls between 5 and 6. And if we can imagine our number line all the way from the square root of 25 to the square root of 36 and think about how far along 34 is between 25 and 36, that can help us get a good estimate. I'm always asking myself, is my number really close to the first integer? Kind of near the middle, but in the bottom half? Kind of near the middle, but closer to our top number? Or really close to our next integer? You can use a number line like this with decimals to help you approximate. This came up in the Desmos that you did yesterday as well, where you were looking for the square root of 40. And you saw that although 40 is not a perfect square, and we know that the exact side lengths would be the square root of 40, we know that the square root of 40 is between the square root of 36 and the square root of 49. And the Desmos walked you through approximating, since these are much closer than these, right? 36 is 6 apart from 40, and 49 is 9 apart from 40. We're going to be somewhere closer to the middle, but on the bottom half. And 6.3 is actually the closest tenth here. So I would want you to be somewhere in here, the bottom half, but closer to the middle. And if you look down here, I can see the actual calculator approximation. So now we're going to move into our notebook. We're going to skip the number line since you've already had practice with that, and you can do that after the video. So I want you to find where it says part 3. One of our tasks on that to-do list said, determine what two integers a square root is between. Sometimes we make mistakes here. Sometimes people say the square root of 27 is between 25 and 36, but it's not. Let me see if I can paste this list in. Yeah, this would be really nice to have over to the side. I'll just make it smaller. So the square root of 27 is between the square root of 25 and the square root of 36. Those are rational radicals where the square roots have a radicand that's a perfect square. So the square root of 27 isn't between 25 and 36. It's between 5 and 6 over here. And to determine which one it's closer to, I know I'm blocking the spot with this list, but it is closer to 5 because 25 is much closer to 27 than 36 is. I'll do another one with you. The square root of 50 is between, and let's again scan down this list. Let me erase from the other ones. I'm going down this list. 50 falls somewhere in here. The square root of 50 is between the square root of 49 and the square root of 64. Numbers that I know, so it's between 7 and 8. And since 50 is really close to 49, I know that this is going to be closer to 7. If I actually did it in my calculator, it would be closest to 7.1. 50 is very close to 49. Let's skip down to one that's negative. We'll do number 5. So the negative square root of 18, I'm just going to look at my positives here. I know that my answer is going to be negative, but it's going to be between the negative square root of 16 and the negative square root of 25. So the negative square root of 18 is between negative 4 and negative 5. And again, it's closer to the first one. This will not always be the case. These 3 that I picked happen to be. So this is going to be closer to negative 4 than it is to negative 5. And if I were to actually do this on my calculator, it would be very close to negative 4.2. That would be the closest decimal approximation, which makes sense because I know that I'm close to here. So I'm within that bottom quartile there. I'm in the bottom half and not close to halfway. You could either pause the video and do these 2 sections, or you could complete all the video notes first and then come back. Notice that I kept pasting the bookmark in for myself so that I could use it in the video. You definitely want to have that on your desk until you become really fluent with your memorization. Now we're going to be doing this without a number line and not just the 2 integers that our number falls between, that an estimate. I'm going to do an example live, but if you want to read through this example, you are welcome to. So we are going to be doing the square root of 40. Now, eventually you won't have all of this set up for you, but we scaffolded it so that you can kind of walk through the steps. So the square root of 40, I could look down my list, is between the square root of 36 and the square root of 49. So the square root of 40 is between 6 and 7. 40 is, let's see, when I look at these radicands are 4 apart, right? Just the radicands. And these radicands are 9 apart. So I would say that this is much closer. So I'm going to be somewhere over here. So I would say that we are sort of close to 6. And that a good estimate here would be something like 6.2 or 6.3. And in fact, when I do this on my calculator, 6.3 is closest. But again, I would take 6.2, I would take 6.3, and I would take 6.4. If you wanted to get even more exact, which isn't required, in addition to just multiplying 6.3 times 6.3, and then 6.2 times 6.2, or 6.4 and 6.4, we could actually look and we could say, well, from 36 to 49, those are 13 apart. And 36 to 40, those are 4 apart. So a good guess would be 6 and 4/13 of the way across. This will typically give you an estimate to within 100th or even 1,000th, depending on how big the number is. And if I were to actually do the long division for 4/13, I would get 0.307, and it keeps going from there, so I can see how accurate that is. Let's do one more. So the square root of 60, I know that that's between the square root of 49 and the square root of 64. So it's between 7 and 8. Again, these have to be consecutive integers. I couldn't say it's between 6 and 8. I want to know the closest integers. Now, 49 and 60, those radicands are 11 apart. And these radicands are 4 apart. So I would say it's sort of close to 8. So I definitely want to be somewhere in the top area here, between 7 and 8. So I would probably guess something like 7.8. Now when I do it on my calculator, the real answer here is 7.7. That's going to be the closest estimate to the nearest tenth. Again, I would take either of those answers. So what I want you to do is I want you to try these 4, and then you could check them on a calculator and see how close they are. If you're within 0.1, that is a perfectly fine estimate. If you want to read more in the example and try to estimate these to the nearest hundredth or even thousandth, you're welcome to, but it is not required. Once you're done, please move on to the next thing on your to-do list.